So let's look at dividing fractions. So the first problem we're going to look at is how we divide a whole number with a fraction. So in this case, we've got 6 divided by a half. Well, the first thing I want to do is represent the whole number of 6 as an improper fraction. Now, the denominator of any whole number is always 1. So this problem is simply 6 over 1 divided by a half. Now, with division problems with fractions, what we want to do is we actually want to do a little trick that helps us make this problem a lot simpler. Rather than trying to divide by a half, what we can do is we can flip this fraction. And when I say flip the fraction, I mean flip the second fraction, the one that we're dividing by, and then change our symbol to multiply. All right, because dividing by a half is actually the same as multiplying by 2. We'll talk about that in a future video. All right, but essentially what this now becomes is a multiplying fractions problem, and in our last video we've shown that to multiply fractions together, we simply multiply our numerators together, so this is 6 times 2, and our denominators together, which is 1 times 1. Alright, now 6 times 2 is going to be 12, 1 times 1 is 1, and 12 divided by 1 is 12. Okay, so our rules here is change the division problem into multiplication problem by flipping the value, like flipping the fraction that you're dividing by. Now, if they're already in fraction form for us, such as the 4/5 divided by 2/3, all right, we don't need to worry about doing anything at the start beyond just flipping the second fraction and changing it to multiply. So in this case, we're multiplying by 3 over 2, and that's the equivalent statement. From here, we multiply the numerators and the denominators. So our numerators multiplied with each other is 5 times 3. Denominators is 4 times 2. 5 times 3 is 15. 4 times 2 is 8. And we could leave it here because this is in simplest form in terms of an improper fraction. However, if you want it as a mixed fraction, you can see that 8 goes into 15 once and leaves 7 left over. Okay, so once again, it's up to you whether or not you do this extra step. Personally, I generally leave the answer here unless there's a reason for wanting it in mixed form. All right. Now, the only thing that you need to be aware of is what happens when we've got mixed fractions and we're dividing. Well, the first thing we need to do is we need to represent a mixed fraction as an improper fraction. And once we've got that, we do the same little trick. So we've got 1 2/3 here, which means we've got 1 times 3 is 3. Add the 2/3 is going to be, 5. So we've got 5/3 divided by 2.5. So 2 times 2 is 4. Add the 1 is 5. So it's 5 on 2. Okay. If you want to know how to do that conversion, that's in an earlier video. However, we've got a division problem with fractions. To do this, we flip the second fraction and we multiply. Okay, so now that allows us to multiply the numerators with the denominators. So this is, I should be doing an equal sign each time here. 5 times 2 over 3 times 5, which is going to be 10 over 15. And then this one here, I can actually simplify. So I should simplify anytime I notice this. And it's because 10 and 15 both divide by 5. So 10 divides by 5 twice. 15 divides by 5 3 times. So this multiplication problem ends up equaling 2/3. Now, just to summarize, dividing fractions, it is very similar to multiplying. In fact, we make it a multiplication problem. But we have to make sure we've got fractions first, so improper fractions or proper fractions, and then we flip what we're dividing by and we change it into a multiplication problem instead.